Purpose of this video clip is to apply the law of conservation of momentum to simple collisions. The law of conservation of momentum says that whatever amount of momentum you have initially, you have to have the same amount of momentum final. So we're going to put that in our key concept section. The sum of all initial momentums is equal to the sum of all your final values for momentum. And now we're going to apply that to the real-world situation of, for example, a football player being tackled. Prior to the tackle, there's an amount of momentum, and after the tackle, there should be the same amount of momentum. So this first example, we have a 95 kilogram halfback moving at 4.1 meters per second is tackled from behind by an 85 kilogram cornerback running at 5.5 meters per second in the same direction. And we want to find their mutual speed immediately after the tackle. So let's draw a quick picture of this event. Okay, well, we know that the law of conservation of momentum states that whatever amount of momentum we had at the beginning, we should have the same amount of momentum in the end. So at the beginning, before the tackle happens, we have, just make these blue, like the initial amounts of momentum are the two separate velocities times their masses. Now, just to remind us that momentum is quantified by mass times velocity. Right, so the initial amount of momentum should be m1 v1 initial plus m2 v2 initial for the two players. Now, afterwards, they're going to be moving together, so you can consider their total mass we're going to call m final, because they're going to be considered one object at that point, all put together. Now this question asked for final velocity, so we're going to have to solve for final velocity. Well, in order to do that, just divide both sides by mass final. And at this point, you've solved for V final. So you plug in your numbers to this fraction right here, and you're going to have the initial mass of 85 kilograms was going 5.5 meters per second, plus the other mass of 95 kilograms was going 4.1 meters per second. All of that divided by the total mass final of 95 plus 85 is 180 kilograms. And we should get a final velocity of, looks like about 4.8 meters per second. Okay, now you try. Okay, the next example is we've got a railroad car on a frictionless track with a constant speed of 18 meters per second, and then it obtains a load of 5,350 kilograms. When it's initially at rest, that amount of mass is dropped in the car. So what will the new car's speed be? Okay. I'll draw the picture, then you want to attempt the problem, pause the video, and play it when you're ready.